So the next question is, without expanding, prove that this determinant is exactly equals to this one. So you have to prove this without expanding. So you have to use the row operations and column operations, and I have discussed it already in the previous video in the property of determinants, right? Okay. Now let's do it. So LHS A, B, C, A square, B square, C square, BC, CA, AB. This one. So this equals to ABC, A square, B square, C square, and 1 by A, 1 by B, and 1 by C. Just taking out common factor as common factor from the third column ABC. इसको हम कॉमन फैक्टर के तरफ इसको हम निकालते हैं थर्ड कॉलम से, राइट? एंड taking out as common factor from third column, right? This one. Now this equals to you know very well that any number, if we multiply a scalar with a determinant, then you have to multiply it with only any row or with any column. So हम लोग इस a को मल्टीप्लाई कर सकते हैं फर्स्ट रो के साथ, b को मल्टीप्लाई कर सकते हैं सेकेंड रो के साथ, और c को मल्टीप्लाई कर सकते हैं थर्ड रो के साथ. Then what will be? It will be a square. I am multiplying a with first row and a cube, and it will be 1. I am multiplying b with second row, so this will be b square, b cube, and 1. Multiplying c with third row, and this will be c square, c cube, 1. This one. So this equals to, now if a negative sign, so a square, b square, c square, 1 1 1, and a cube, b cube, c cube. Once again, just change the first column into second column and second column into first column. So this will be once again negative, so negative of negative positive, so this will be 1 1 1, and a square, b square, c square, a cube, b cube, c cube. Proved. So this is a good question. Okay, so next question. So the next question is, evaluate this determinant. So you know how to evaluate this one, and I will prefer to evaluate this with respect to third column. Why? Because there is a zero term, right? So calculation will be much more easy. Okay, so the answer is determinant cos alpha, cos beta, sin beta, minus sin alpha, and minus sin beta, cos beta, 0, and sin alpha, cos beta, sin alpha, sin beta, cos alpha. This equals to, I am expanding it with respect to third column. So the first row and third column, so positive sign, right? So that's why minus sin alpha into, so this row and this column is deleted, so this one is minus sin alpha, sin square beta. I am multiplying this with this, and negative of this one, so minus sin alpha cos square beta, this one, and next is 0, so that will be 0, and next is cos alpha, so sign will be positive, so cos alpha into So this one and this one is deleted, so cos alpha into cos square beta, this one and negative of negative, so positive sin beta cos alpha sin square beta, this one. So this equals to, just see here, minus sin alpha, so you can take a common factor, this one, so minus will be plus, so sin square alpha into, so this one is sin square beta and this one is cos square beta, so sin square beta plus cos square beta, and this one is just take common as cos alpha, so plus cos square alpha into, so here the remaining factor is cos square beta plus sin square beta, and you know very well that this part is 0 and this part is 0, so this equals to, sorry, this part is 1, I am so sorry, so 1 sin square alpha plus cos square alpha, and again sin square alpha plus cos square alpha is 1, so this is the answer, right? Okay, so next question, and delta is equals to this one, then so that either a plus b plus c is equals to 0 or a equals to b equals to c. Now we will use the elementary row operation and column operation to evaluate this one, right? Okay, now delta is equals to b plus c, c plus a, and a plus b, this one c plus a plus b, b plus c, and a plus b, b plus c, c plus a, this one. So this equals to just I am doing here, I am adding the whole rows, that means r1 goes to r1 plus r2 plus r3, so I am changing r1, how? I am adding all the 3 rows, so see here, b plus c, c plus a, and a plus b, so ultimately it will be b plus c plus c plus a plus b. That means b is how much times? 2 times. A is also 2 times, c is also 2 times, that means 2 into a plus b plus c, this one. Similarly, the second element also will be 2 times a plus b plus c, and third one is also a plus b plus c, and third one also will be 2 times a plus b plus c, this one, and the remaining will be same, c plus a plus b, and a plus b, b plus c, b plus c, c plus a. Now see here, if we take a common factor as 2 times a plus b plus c, then all the elements will be 1, so 2 into a plus b plus c, 1 1 1, this one is c plus a plus b, b plus c, and a plus b, b plus c, c plus a, this one. Now just subtract this equals to 2 into a plus b plus c, this one, this is 0. I am subtracting column 3 from column 1. I am subtracting column 3 from column 1, so this will be 0, and c plus a is minus b minus c, so c plus a minus b minus c, so ultimately a minus b, so this one will be a minus b. Next is this one, b minus c, so b minus c. Again I am subtracting third column from the second column, then it is also 0, and this one will be a minus c, so this one will be a minus c, and this one will be b minus c, this one will be b minus c, and this is 1, this is B plus C, this is C plus A, right? This one. Now just break it with respect to the first row, then 1 into A minus B. Okay, now expand it with respect to first row, then what will be? If we expand it with respect to first row, it will be this equals to 2 times A plus B plus C into 1 into just multiply this one and this one, so A minus B into B minus A into A minus B into B minus A, and minus A minus C minus A minus C into A minus C into B minus C minus A minus C into B minus C into B minus C into B minus C. So this equals to 2 into A plus B plus C, and if we break it and rearrange it, you will get here A minus B into B minus C into B minus C. This one. Okay. Now, given there in the question that delta equals to 0. That means according to question, so according to question, we can write here 2 into A plus B plus C into A minus B into B minus C is equals to 0, right? Now if we take these two as one factor, then this implies that either A plus B plus C is equals to 0, or A minus B into B minus C is equals to 0, and this again implies that A equals to B equals to C. This is the proof. Okay, now next question. The next question is question number 5. Solve the equation this equals to 0, right? Where given A is not equals to 0. Now see here, if we consider this as delta, then delta is equals to x plus A, x plus A, x, and x plus A. This one. So this equals to, you can write here, this equals to 3x plus A, 3x plus A, 3x plus A, x plus A, x, this one is x plus A. How we can get it? I am changing column 1 by column 1, C1 goes to C1 plus C2 plus C3. I am changing column 1 by adding all these three columns, and putting it throughout the first column, right? So you can take common factor 3A plus 1 from the first column, so you can write here, so this equals to 3x plus A, 1 1 1, and x plus A, x, and this one is x plus A, this one. So this equals to, just subtract the second row from first row and third row from second one. So this equals to 3x plus A into 0, this is minus A, this is 0, and this is also 0, this is A, this is minus A, this is minus A, and on x plus A. What I have done? I have done R1 goes to how? R1 minus R2, फर्स्ट रो से मैंने सेकंड रो को सब्ट्रैक्ट किया, ओके, और R2 goes to R2 minus R3. This operation is applied here, right? Now if we break it with respect to the first column, then you will get 1 into, this is the third row and first column, so sign will be positive. So this equals to 3x plus a into 1 into, so this row, sorry, this column and this row is deleted, so minus minus plus a square, so a square, and this one is 0, minus 0, so ultimately this one will be a square into 3x plus a. Now according to question, delta equals to 0, right? Therefore a square, a square into 3x plus a is equals to 0, implies that x equals to how much? Since a is not equals to 0, so you can divide this equation with a square, so after that this will be 3x plus a equals to 0, that means x equals to minus a by 3. So this is the answer. Okay. And the next question is question number 6. Prove that a square bc ac plus c square, a square plus ab b square ac, ab b square plus bc c square is equals to 4 times a square b square c square. This is a good question, and we will not directly expand this determinant. We will use elementary row operations and column operations on this determinant, and we will get this result eventually. Okay, now let's start. So determinant a square bc ac plus c square and a square plus ab b square ac ab b square plus bc c square. Now if we take a from first column, taking b from second column, and taking c from third column, then it will be a plus b, and this will be exactly b, this one c b, and b plus c, this will be a plus c, and this one will be a, and this one will be c, this one. So this equals to abc into, I am subtracting, I am doing here r1 goes to r1 minus r2 plus r3, r2 और r3 को ऐड करने के बाद उसको r1 से हम लोग सब्ट्रैक्ट करेंगे. Okay, so this will be, the result will be a minus, you have to add this 2, so a plus 2b, that means a minus 2b, it will be exactly minus 2b. For this one, c will be cancelled, so this is also minus 2b, and this will be exactly 0. And next a plus b, a, b plus c, this one. So this equals to, just take common factor minus 2b, so it will be minus 2a b square c, and this one will be 1 1 0, and this is a plus b a, and this is b plus c, this is c, this one. So this equals to minus 2 times a b square c into, just break it with respect to first row, then this will be 1 into, so this row and this column is deleted, so bc minus ab minus ac, this one. Again minus 1 into, equals to minus 2 times a b square c into, within bracket, bc minus ab minus ac, and minus ac minus bc plus ab, this one. So ab is cancelled. and BC cancelled. So 2 times minus 2 times AB. So this equals to minus minus plus 2 into 2 into A B square C into 2AC. So this equals to 4 A square B square C square root. So the next question is question number 7. If A inverse is equals to this one and B is equals to this one, then find AB whole inverse. And you know very well that AB whole inverse is equals to B inverse A inverse. Now you have to calculate B inverse from this one and just multiply the B inverse with A inverse is already given here and get the result. I am not doing here. Try yourself. Okay, the next question is, let A is equals to this matrix, then verify that adjoint of A inverse equals to adjoint of A inverse, and A inverse of inverse is equals to exactly A. So you have to calculate first the adjoint of A, right? Then you have to find the inverse of adjoint. So you know that the adjoint adjoint of A whole inverse is इक्वल्स टू, इसका जब एडजॉइंट लेते हैं तो यहाँ पर इनवर्स, व्हाट डज इट मीन? ए इनवर्स इक्वल्स टू एडजॉइंट ऑफ ए डिवाइडेड बाय this one, determinant of A. So according to this definition, it will be adjoint of, again adjoint, so adjoint of A, this one, by determinant of A. Now to calculate this one, adjoint of A, just use the theorem, this one, adjoint of A, this one is equals to determinant of A to the power n minus 2 into A. Use this result to find the adjoint of adjoint A. Then you will get the inverse of adjoint and adjoint of A inverse. You have to first calculate A inverse, then you have to take the adjoint. This is the only calculation based problem, and that's why I am skipping it. I am going to the question number. Next question is question number 11. I am skipping question number 9 and 10 because you have to evaluate the determinants given in question number 9 and 10, and you know how to expand a determinant, right? So I am skipping this. The next question is question number 11. Using the properties of determinant, prove that this one. So this is a good question. So you have to use the properties of determinant and you have to prove this one. Now each and every question will give you a hint, right? And that hint you have to understood. See here, this is a factor alpha plus beta plus gamma. Now if we think how we can get alpha plus beta plus gamma as a common factor. Now see here, if we add third column with first column, what will be? Alpha plus beta plus gamma. This one, alpha plus beta plus gamma. This one is also alpha plus beta plus gamma. So this is the correct technique to find this one. So the determinant given here, alpha, beta, gamma, alpha square, beta square, gamma square. Next one is beta plus gamma, gamma plus alpha, and alpha plus beta. So this one, so this equals to alpha plus beta plus gamma. This one is also alpha plus beta plus gamma. This one is also alpha plus beta plus gamma. This one is alpha square, this one is beta square, this one is gamma square, and this one is beta plus gamma, gamma plus alpha, and alpha plus beta. This one, and I have applied C1 goes to C1 plus C2, C3, C1 plus C3. So this is the operation. So you can take the common factor, this one, so alpha plus beta plus gamma, this one, so this will be 1 1 1, this one, and alpha square, beta square, gamma square. This one is beta plus gamma, gamma plus alpha, and this is alpha plus beta, this one. So this equals to, now subtract the second row from first row and subtract third row from second row, then it will be alpha plus beta plus gamma, this into this one is 0 and this is alpha square minus beta square. If we subtract second row from first row, then this will be beta minus alpha, beta minus alpha. Subtract third row from second row, so this will be 0, this will be beta square minus gamma square, and this will be gamma minus beta, this one. So this equals to, now take as a common factor alpha minus beta from the first, now take common factor alpha minus beta from the first row and beta minus gamma from the second row. Alpha minus beta, alpha square minus beta square, that means alpha plus beta into alpha minus beta, and I have take common factor as alpha minus beta, so the remaining term is alpha plus beta. So this one is will be alpha plus beta, this one is minus 1. Why? Because I have taken common factor as alpha minus beta, but here is beta minus alpha. Okay, next one is, this is also 0, this one is beta plus gamma, this one is minus 1, and this one is 1 gamma square alpha plus beta, this one. Now if we expand this with respect to, sorry, one more term will be here, beta minus gamma, beta minus gamma. So this equals to, break this determinant with respect to first column, so alpha plus beta plus gamma into alpha minus beta into beta minus gamma into 1 into, these two terms will be 0, so 1 into minus alpha minus beta, and this will be minus minus plus, so plus beta plus gamma, beta beta cancel, that means gamma minus alpha. So this will be exactly alpha, so this will be gamma minus alpha, so gamma minus alpha. This is the proof. 12 to 15 all are same, you can try yourself. I am discussing question number 16. Now you have to solve this system of linear equations, right? Now if we consider 1 by x as p, 1 by, so let us consider 1 by x is equals to p, 1 by y is equals to q, and 1 by z is equals to r, right? So this equation will be, so the given equation will, first equation will be 2p plus 3q plus 10r is equals to 4. This one will be 4p minus 6q plus 5r is equals to 1. This one will be 6p plus 9q minus 20r is equals to 2. And this can be expressed in terms of matrix, right? So the matrix will be Ax is equals to B, where A is equals to the coefficient. Okay, next question. The next question is, if A, B, C are in AP means arithmetic progression, then the value of this determinant is option A 0, option B is 1, option C is x, option D is 2x. Now let's calculate this one. So the given determinant is x plus 2, x plus 3, x plus 4, x plus 3, x plus 4, x plus 5, x plus 2a, x plus 2b, and x plus 2c. Okay, this is a good question. Okay, next is this one is equals to, I am subtracting second row from the first, I am subtracting first row from second row. So this one will be x plus 2, x plus 3, and x plus 2a. So this one will be, I am subtracting first row from second row. So this one will be 1, this one will be 1, and this one will be 2 times b minus a. And I am subtracting second row from third one. So this one will be 1, 1, and this one will be 2 times b minus c. This one. So I have applied R2 goes to R2 minus R1, and R3 goes to R3 minus R2. This one. So this equals to x plus 2, x plus 3, and x plus 2a. This one. And this is 1. This is 1, 1, 1, 1. Now, since A, B, C are in AP, then you can write here B minus A is equals to C minus B. So B minus A is equals to C minus A. Okay. Now, so this will be C minus B. This will be C minus B. Exactly, C minus B. So B minus A is equals to C minus B. So you can write here C minus B. So 2 times C minus B, and this is 2 times C minus B. Now see here, the second row and the third row are same, and if the any two row or any two column of a determinant are identical, then the determinant value is exactly 0. So this equals to 0. So this one is the correct answer. So question number 18, you can solve it. So I am discussing question number 19, that A is equals to this matrix where 0 is less than equals to theta less than equals to 2 pi. Then the determinant of A is equals to 0, determinant of A belongs to 2 to infinity, determinant of A belongs to 2 to 4, open interval 2 to 4, and determinant of A belongs to close interval 2 to 4. So this is a good question. Okay, and answer is answer. So you have to calculate the determinant, na? So let's calculate. So determinant of A is equals to 1 sin theta 1 minus sin theta 1 sin theta, and minus 1 minus sin theta 1. This one. Okay. Now this equals to 1 minus 1 0, and sin theta minus sin theta, this is also 0, and this one is 2, and minus sin theta 1 sin theta minus 1 sin. This implies that det A belongs to 2 to 4. So this is the correct answer. Okay, thank you guys. Hope all of you have enjoyed my video. Please like, share and comment, and subscribe my channel to get the new videos. चलो मिलते हैं नेक्स्ट वीडियो में नया चैप्टर के साथ. थैंक यू.